The Three Gorges Dam, History, Present and Future. Introduction. The Three Gorges Dam, located on the Yangtze River near Yichang in Hubei Province, China, is the world's largest hydroelectric power station in terms of installed capacity, which stands at 22,500 megawatts MW. Its construction has been a monumental engineering feat aimed at flood control, power generation, and improved navigation along the river. However, it is also a focal point for environmental and social controversy. Historical context. Early proposals and planning. The idea of constructing a dam across the Yangtze River dates back to the 1920s, with prominent figures like Sun Yat-sen advocating for a large-scale project to harness the river's power. However, significant action did not occur until the mid-20th century. In 1953, Chinese leader Mao Zedong ordered feasibility studies to explore various sites for dam construction. Following Mao's directive, detailed planning commenced in 1955. But the project faced delays due to political and economic upheavals, including the Great Leap Forward and the Cultural Revolution. Approval and construction. In 1992, after many years of debate and planning, the National People's Congress approved the construction of the Three Gorges Dam despite significant opposition from environmentalists and local residents. Construction officially began on December 14, 1994, and the dam's main structure was completed by 2006. It began generating electricity in 2003 and reached full operational capacity in July 2012, with the last of its 32 main generators coming online. Structure and capacity. The Three Gorges Dam is a concrete gravity dam that is approximately 2,335 meters long and 185 meters high. The dam's reservoir stretches over 600 kilometers upstream, creating a massive body of water that significantly alters the local geography. The construction utilized around 28 million cubic meters of concrete and 463,000 tons of steel. Power generation. The dam is capable of generating an average of 95 to 100 terawatt-hours (TWh) of electricity annually. In 2020, it set a record by producing 111.88 TWh, surpassing the previous world record held by the Itaipu Dam in Brazil. Functions and benefits. Flood control. One of the primary purposes of the Three Gorges Dam is flood control. The reservoir can hold up to 39.3 billion cubic meters of water, which is intended to reduce the frequency of major flooding events in the Yangtze River basin. It is estimated that the dam can decrease the likelihood of significant flooding from once every 10 years to once every 100 years. However, there are ongoing debates regarding its effectiveness, particularly highlighted during severe flood events in 2020. Navigation improvement. The dam has also transformed navigation along the Yangtze River. It allows larger vessels to travel further inland, significantly increasing shipping capacity. The installation of 5-tier shiplocks enables ships up to 10,000 tons to bypass the dam, while a shiplift allows smaller vessels to transit more quickly. Social and environmental impact. Displacement of residents. The construction of the dam has had profound social consequences, with estimates suggesting that over 1.3 million people were displaced from their homes. Critics argue that the actual number may be higher, and many of those relocated faced challenges in adapting to new environments, including job losses and a lack of infrastructure in resettlement areas. Environmental concerns. The environmental impact of the Three Gorges Dam has been significant and controversial. The creation of the reservoir has led to increased landslides and altered ecosystems affecting local flora and fauna. The dam's construction submerged numerous historical and cultural sites. And ongoing pollution from industrial and agricultural runoff has raised concerns about water quality in the reservoir. The dam's alteration of sediment flow has also created problems downstream, potentially increasing the risk of flooding in cities like Shanghai. The lack of sediment reaching the riverbanks could weaken their stability, making them more vulnerable to severe weather events. Future prospects. Technological innovations. As the demand for renewable energy continues to grow, the Three Gorges Dam is likely to play an essential role in China's energy strategy. Advances in technology could improve the dam's efficiency and output. Future projects may include additional hydroelectric facilities along the Yangtze River, enhancing the overall capacity of the region's hydroelectric infrastructure. Ongoing challenges. Despite its potential benefits, the dam's future is not without challenges. Continued scrutiny of its environmental and social impacts will be necessary to ensure that it does not exacerbate existing issues. The Chinese government has also faced criticism regarding the resettlement processes for displaced communities, and efforts to mitigate environmental degradation will be crucial. Conclusion. The Three Gorges Dam stands as a symbol of modern engineering and China's ambition to harness natural resources for economic growth. While it has achieved notable successes in power generation and flood control, its construction has also brought significant social and environmental challenges. The future of the dam will depend on how these issues are addressed, balancing the need for energy with the imperative of sustainable development. As the world moves toward greener energy solutions, the lessons learned from the Three Gorges Dam will be critical in shaping similar projects globally. The Three Gorges Dam (TGD) is a monumental engineering project situated on the Yangtze River in China, with a history and impact that are both profound and controversial. It is essential to consider the counterintuitive aspects of this massive infrastructure undertaking, which has become a focal point of environmental, social, and economic discourse. 1. Flood control versus flooding reality. While the TGD was designed to reduce the frequency and severity of floods downstream, it has faced scrutiny regarding its effectiveness. Proponents claimed it would decrease the likelihood of catastrophic floods from once every 10 years to once every 100 years. However, the reality of severe flooding in 2020 challenged this narrative, as critics pointed out that the dam's design was insufficient to handle the unprecedented water levels, leading to significant flooding in areas that were expected to be protected. This contradiction between the intended flood control benefit and the actual occurrence of flooding highlights the complexities and limitations of large-scale engineering solutions. 2. Environmental impact versus renewable energy source. The TGD is heralded as a source of clean energy, boasting the world's largest hydroelectric power capacity at 22,500 megawatts. However, the environmental costs associated with its construction and operation are substantial and often overlooked. Critics argue that the dam has led to increased soil erosion, sedimentation, and a decline in biodiversity, particularly affecting endemic species like the Chinese paddlefish and the Yangtze sturgeon. The dam's reservoir has also been linked to more frequent landslides and seismic activity in the region, presenting a paradox where a renewable energy project simultaneously contributes to environmental degradation. 3. Economic growth versus displacement and cultural loss. The TGD was anticipated to spur economic development by improving shipping routes and generating power. However, the economic benefits come at a significant social cost, with estimates of displaced people ranging from 1.3 million to potentially over 31 million when including indirect displacement due to secondary migration pressures. The destruction of historical and cultural sites further complicates the economic narrative, as the loss of heritage poses a deep cultural cost that cannot easily be quantified in economic terms. This raises questions about the true price of progress and whether it can ever be justified against the backdrop of human and cultural displacement. 4. Infrastructure improvement versus increased vulnerability. The dam's construction included advanced navigation locks to facilitate shipping, which ostensibly enhances trade and transportation efficiency. Nonetheless, this infrastructure improvement has also made certain areas more vulnerable to potential disasters, including concerns about the dam's structural integrity. Reports of hairline cracks and fears of catastrophic failure have led to debates about the dam's safety, particularly in the context of military threats and natural disasters. This juxtaposition of enhanced infrastructure leading to increased vulnerability reflects a complex dynamic that challenges straightforward assessments of the dam's benefits. 5. National pride versus international criticism. The TGD is often regarded as a symbol of national pride and engineering prowess in China. However, it has also become a target of international criticism for its environmental and social repercussions. The dichotomy between nationalistic pride and global scrutiny underscores a tension in modern China's approach to development. Where significant infrastructure projects are celebrated domestically while facing condemnation abroad for their ecological and humanitarian impacts. This highlights the challenges of reconciling national aspirations with global environmental standards and human rights considerations. 6. Technological advancement versus natural disasters. The dam represents a significant technological achievement in engineering and hydroelectric power generation, yet it is paradoxically vulnerable to the very natural forces it aims to control. The increased risk of landslides and earthquakes due to the dam's presence in a seismically active region raises questions about the sustainability of such massive projects. This contradiction illustrates the limitations of human engineering in the face of nature's power, reminding us that technological solutions can sometimes exacerbate existing problems rather than solve them. In conclusion, the Three Gorges Dam is emblematic of the tensions and contradictions inherent in modern infrastructure projects. While it offers significant benefits in terms of energy production and flood control, its social, environmental, and safety implications reveal a more complex reality. The counterintuitive aspects of the dam's impact challenge us to rethink the narratives of progress and development, urging a more nuanced understanding of the interplay between human ingenuity and the natural world. The Three Gorges Dam TGD is a monumental engineering project in China, often associated with both remarkable achievements and significant controversies. While much attention is given to its size, power generation capacity, and the immediate benefits it provides, there are crucial aspects of its impact and history that are often overlooked. Here we delve into these underappreciated elements, highlighting their significance for understanding the dam's broader implications. 1. Historical context and long-term planning. The idea of the Three Gorges Dam dates back to the 1920s, with serious discussions taking place in the 1950s. This long history shows how deeply ingrained the vision of the dam was within Chinese political and social aspirations. However, it also reveals the complexity and the challenges of implementing such a grand project over decades, including political instability, economic challenges, and environmental concerns. The dam's construction reflects a continuity of Chinese ambition and technological aspiration, yet it also underscores the difficulties of bridging historical dreams with practical reality. Significance. Understanding the historical context helps provide insight into the socio-political landscape of China over the decades. It illustrates how national ambitions can drive large-scale projects, even amid significant opposition and challenges. 2. Displacement and social impact. While it is widely reported that approximately 1.3 million people were displaced due to the dam, some estimates suggest that the number could be as high as 3 million. This discrepancy in figures often leads to underestimating the social upheaval caused by the dam's construction. Many displaced individuals faced severe hardship, including loss of livelihood, cultural dislocation, and inadequate resettlement support. Significance. The scale of human displacement and its effects on communities are often glossed over in discussions about the dam's efficiency. This aspect highlights the human cost of development and the necessity for comprehensive resettlement policies in large infrastructure projects. It raises ethical concerns about prioritizing economic development over the well-being of vulnerable populations. 3. Environmental consequences. The environmental impacts of the Three Gorges Dam are significant and multifaceted. Yet they are often overshadowed by the dam's economic benefits. The dam has altered local ecosystems affecting water quality, fish populations, and biodiversity. Notably, the extinction of the Yangtze River dolphin is attributed to the dam's construction and its ecological implications. Moreover, the dam has led to increased landslide occurrences in the region, raising concerns about geological stability. Significance: the environmental ramifications emphasize the need for a holistic view of infrastructure projects that includes ecological sustainability. Ignoring these aspects can lead to irreversible damage to ecosystems, which in turn affects local communities and economies dependent on those natural resources. 4. Debate over flood control efficacy. The dam was primarily justified on the grounds of flood control. However, its performance during significant flood events such as those in 2020 has raised questions about its effectiveness. Critics argue that while the dam does reduce flood severity, it cannot fully prevent flooding from tributaries downstream. This discrepancy highlights the limitations of engineering solutions in addressing natural disasters. Significance: the debate over the dam's flood control capabilities serves as a cautionary tale about reliance on large-scale engineering solutions. It underscores the importance of incorporating a range of strategies for disaster management, including natural floodplain restoration and community preparedness. 5. Cultural heritage loss. The flooding caused by the dam submerged numerous archaeological sites and cultural landmarks, leading to the loss of invaluable historical heritage. Efforts to document and recover artifacts were made, but many sites were lost forever. The area's rich cultural history and its significance to various ethnic groups were disregarded in the pursuit of modernization. Significance: the cultural heritage loss associated with the Three Gorges Dam serves as a reminder of the need to balance development with the preservation of history. It raises critical questions about how societies value and protect their cultural identities amidst modernization efforts. 6. Technological and engineering challenges. Despite being celebrated as an engineering marvel, the Three Gorges Dam faced substantial technological challenges during its construction and operation. Reports of cracks in the dam and concerns about its structural integrity have led to ongoing scrutiny. The dam's design and construction process involved significant innovation but also highlighted potential vulnerabilities in such large-scale projects. Significance: the technological challenges faced by the dam reflect the complexities of modern engineering and the risks associated with large infrastructure projects. They underscore the importance of rigorous safety protocols and continuous monitoring in ensuring structural reliability. 7. Geopolitical implications. The Three Gorges Dam holds geopolitical significance, particularly in relation to water resource management and regional power dynamics. The control of the Yangtze River's flow can impact neighboring countries and regions, leading to potential conflicts over water rights. As China continues to expand its hydropower initiatives, the TGD serves as a model for other nations, influencing global hydropower strategies. Significance: the dam's geopolitical implications highlight the interconnectedness of water management and international relations. They illustrate the need for collaborative approaches to transboundary water resources, emphasizing diplomacy over conflict. 8. Economic disparities and regional development. While the dam is heralded for boosting the local economy through energy generation and improved shipping routes, the benefits are not uniformly distributed. Regions and populations directly affected by the dam have often seen fewer economic gains compared to urban centers that benefit from the energy produced. This has led to economic disparities that can exacerbate social tensions. Significance: the economic disparities resulting from the dam's development underscore the necessity for equitable development policies that ensure all affected populations share in the benefits of major infrastructure projects. Conclusion: the Three Gorges Dam is a complex and multifaceted project that embodies the challenges and contradictions of modern development. While its engineering achievements are commendable, the overlooked aspects such as human displacement, environmental impact, cultural loss, and socioeconomic disparities underscore the importance of a comprehensive approach to evaluating such monumental projects. The dam serves as a critical case study for future infrastructure initiatives, emphasizing the need to balance progress with sustainability and social equity. 1. Historical context and development. The Three Gorges Dam (TGD) project has a long and complex history dating back to the 1920s. It gained momentum under Mao Zedong in the 1950s and was officially approved by the National People's Congress in 1992. Construction began in 1994 and it was completed in 2006. The dam was built to address persistent flooding along the Yangtze River, improve navigation, and generate hydroelectric power. The historical context reflects China's socio-political evolution, with the dam serving as a symbol of modernization and a significant engineering achievement. 2. Economic and energy impact. The TGD is the world's largest hydroelectric power station with a total installed capacity of 22,500 megawatts. In 2020, it generated 111.88 TWh of electricity, setting a world record for annual power generation. The dam has significantly contributed to China's energy supply, which is crucial given the country's rapid industrialization and urbanization. However, the dam's energy output is debated relative to China's overall power needs, as it only accounts for about 1.7% of the national demand. 3. Social and environmental consequences. The construction of the TGD led to the displacement of approximately 1.3 million people, with critics suggesting the number could be much higher. This mass relocation caused considerable social upheaval, with many affected individuals facing difficulties in finding employment and adapting to new environments. Additionally, the dam has had significant environmental impacts, including increased landslide and earthquake risks, altered ecosystems, and declining biodiversity, particularly affecting several endangered species in the Yangtze River basin. 4. Controversies and future challenges. The TGD has been subject to extensive criticism and controversy, particularly regarding its effectiveness in flood control and its environmental and social costs. Despite its intended goal of reducing flood risks, the dam's role came into question during severe flooding events such as those in 2020. Looking forward, the dam faces challenges related to sedimentation maintenance and the need for sustainable management of the reservoir and surrounding areas. The ongoing debates surrounding the TGD reflect broader discussions about the balance between development, environmental conservation, and social equity in China's rapid modernization. 1. Hoover Dam, USA. The Hoover Dam, located on the border between Arizona and Nevada, was constructed during the Great Depression and completed in 1936. It was built to control flooding, provide irrigation water, and generate hydroelectric power. The dam created Lake Mead, which is one of the largest man-made lakes in the United States. Similar to the Three Gorges Dam, the Hoover Dam's construction displaced thousands of people and submerged existing towns and natural landscapes. The dam has been crucial for water supply and power generation in the southwestern United States, but it has also faced criticism for its environmental impact, particularly regarding the alteration of local ecosystems and fish populations. 2. Itaipu Dam, Brazil/Paraguay. The Itaipu Dam, located on the Parana River between Brazil and Paraguay, was completed in 1984. It is one of the largest hydroelectric power plants in the world, providing a significant portion of the electricity consumed in both countries. The construction of Itaipu led to the displacement of around 10,000 people and flooded vast areas of land, including parts of the Iguazu National Park. Similar to the Three Gorges Dam, Itaipu's construction has been praised for its energy production capabilities but criticized for its environmental consequences, including habitat destruction and changes to local water systems. 3. Aswan High Dam, Egypt. The Aswan High Dam, completed in 1970, is located on the Nile River in Egypt and was constructed primarily for flood control, irrigation and hydroelectric power generation. The dam created Lake Nasser, one of the world's largest artificial lakes. While the dam has significantly improved agricultural productivity and electricity generation in Egypt, it has also led to the displacement of approximately 100,000 people and submerged numerous archaeological sites, including the temples of Abu Simbel. Environmental issues such as changes in sediment flow and impacts on fisheries parallel those faced by the Three Gorges Dam, highlighting the complex trade-offs involved in large-scale hydroelectric projects. Future outlook for the Three Gorges Dam, predictions for 2025 and beyond. 1. Sustainability and environmental management. As the world increasingly focuses on sustainability, the Three Gorges Dam will likely enhance its environmental management strategies. Ongoing efforts to mitigate the ecological impact, such as improving wastewater treatment upstream and restoring natural habitats, are expected to be prioritized. The Chinese government may invest in advanced technologies to monitor water quality and biodiversity in the Yangtze River, aiming to address the ongoing concerns about pollution and habitat destruction. 2. Technological innovations. The future of the Three Gorges Dam will likely see the introduction of cutting-edge technologies in hydropower generation and management. Innovations in turbine design and efficiency could further increase the dam's power generation capabilities while reducing its ecological footprint. Additionally, advancements in predictive modeling and AI may help manage water levels more effectively, optimizing flood control while ensuring the reservoir's ecological balance. 3. Increased climate resilience. Given the rising threats posed by climate change, the Three Gorges Dam will play a crucial role in flood management strategies for the Yangtze River basin. Predictive flood modeling and enhanced monitoring systems could be implemented to improve the dam's responsiveness to extreme weather events. This would potentially reduce the risk of catastrophic flooding, thereby protecting millions of lives in vast agricultural areas downstream. 4. Enhanced energy production. With the global push towards renewable energy, the Three Gorges Dam is expected to maintain its status as a leading hydroelectric power producer. The dam's capacity for energy generation could be increased through technological upgrades and maintenance improvements. By 2025, the dam may further contribute to China's energy mix, helping the country achieve its carbon neutrality goals by 2060. 5. Involvement in regional energy markets. The Three Gorges Dam could be pivotal in China's regional energy strategy, potentially exporting excess energy to neighboring countries. The establishment of power transmission lines and cooperative agreements could facilitate energy trade, enhancing regional energy security and promoting economic cooperation. 6. Socioeconomic development. The dam's influence on local and regional economies is likely to continue. As shipping capacity increases, economic activities in the Yangtze River basin may thrive, resulting in enhanced trade and tourism. The government may focus on developing infrastructure improvements around the dam area, including transport links and urban development projects benefiting displaced communities and new residents alike. 7. Cultural and historical preservation. Amid ongoing discussions about the dam's historical and cultural impacts, future policies may emphasize the preservation of cultural heritage sites affected by the reservoir. Initiatives to document and protect these sites could gain momentum, potentially involving international collaboration and funding. 8. Public perception and policy adjustments. Public sentiment regarding the Three Gorges Dam may evolve as environmental concerns grow. The Chinese government could respond by enhancing transparency and community engagement regarding dam operations and environmental management. Policies may shift to prioritize sustainable development and community welfare, addressing the grievances of those displaced by the dam's construction. 9. Disaster preparedness and response. As natural disasters become more prevalent due to climate change, the Three Gorges Dam's role in disaster preparedness will be critical. Enhanced emergency response plans and infrastructure improvements may be implemented to ensure rapid action during flood events, potentially saving lives and minimizing economic losses. 10. International relations and environmental diplomacy. The Three Gorges Dam could become a focal point in international discussions surrounding water rights and environmental diplomacy. As China engages in dialogues about transboundary water management, the dam may be positioned as a model for managing large-scale hydropower projects sustainably while fostering regional cooperation. Conclusion: the future of the Three Gorges Dam is intertwined with global trends in sustainability, technology, and climate resilience. As challenges persist, proactive measures in environmental management, technological advancement, and community involvement will play essential roles in shaping the dam's legacy. The coming years could see the Three Gorges Dam evolve from a symbol of engineering prowess to a model for sustainable development, balancing energy production with ecological preservation and social responsibility.